Hello, everybody, and welcome back to our discussion in Fundamentals of Surveying. We are still talking about traversing and traverse computations. For this video, I am going to talk about the deflection angle traverse. But before we go and solve and compute some of the problems, let us define or discuss some of the few terms or few theories behind the deflection angle. So a deflection angle is a horizontal angle measured clockwise or counterclockwise from the prolongation of the preceding line to the succeeding line. As you can see from the figure here, this is line AB. And after going on through line AB, the deflection angle is measured from the prolongation. Okay, this broken line here is the prolongation of line AB. Okay, and then this angle measured from this prolongation to the next line BC is called the deflection angle. Okay, so a deflection angle varies from 0 to 180 degrees and must be designated as right or left. Okay, as for this one, as if you are walking, as if you are walking from point A to point B, and then you at point B you should make a turn. Okay, the turn is to the right. Okay, so for every deflection angle you should state whether it's going to the right or going to the left. Okay, in this case this deflection angle here is going to the right. Okay, on the other hand, going from point B to point C and then turning from point C to point D gives us a deflection angle of an angle going to the left. Okay, so it's like you are turning, you are walking here from B to point C, and then you turn left going to point D. That's why the deflection angle is going to the left. Okay, in every deflection angle we must state whether it's going to the right or it's going to the left. This is very important because of this theory. For any closed traverse in which sides do not cross one another, the summation of the deflection angles, considering those turned to the left as being opposite sign to those turned to the right, should be equal to 360 degrees. Okay, so basically the difference between the deflection angle to the right and the deflection angle to the left should be equal to 360 degrees. Okay, it does not matter whether which one is higher. We should get the absolute value of the difference between the right deflection angle and the left deflection angle, and that should be equal to 360 degrees, and that is only applicable for a closed traverse. Okay, if it's an open traverse like this one in the figure, this rule does not apply. Okay, let us take a look at some of the problems. Okay, this is problem number 1. Following are the observed deflection angles of a closed traverse. Okay, so this is a closed traverse, meaning the theory that the difference between the right deflection angle and the left deflection angle should be equal to 360 degrees. Okay, compute the error of closure and adjust the angular values by assuming that the error is the same for each angle. Tabulate values accordingly. Okay, so we have here 7 angles, 7 deflection angles. Okay, we need to get the sum of the angles to the left and the sum of the angles to the right, and then later on we should subtract, and the difference should be equal to 360 degrees. Okay, if it's not equal to 360 degrees, there is an error of closure. The difference between 360 degrees and the difference between the right and left deflection angles is the error of closure. Okay, we shall solve that one first. Okay, first we need to get the sum of the deflection angles to the left. Okay, sum of deflection angles to the left. That's the sum of the deflection angles to the left. Okay, so the sum of the deflection angles to the left, we have angle A, that's 28 degrees. 25 minutes, 00 seconds. We also have angle B with 68 degrees, 03 minutes and 30 seconds. We also have angle C, 120 degrees, 34 minutes, 00 seconds. We also have angle E of 108 degrees, 13 minutes, 30 seconds. And finally, we have angle G with 110 degrees, 00 minutes, and 30 seconds. Okay, we should get the sum of these 5 angles here, A, B, C, E, and G. And we should come up with, okay, the sum is 435 degrees, 16 minutes, and 30 seconds. Okay, that is the sum of the left deflection angles. Okay, we should also get the sum of the deflection angles to the right. Okay, so the sum of the deflection angles to the right, we only have 2. That's angle D and angle F. Okay, for angle D, we have 58 degrees, 30 minutes, 00 seconds, and then plus angle F, that's 16 degrees, 50 minutes, then 00 seconds. Okay, we should get the sum of 75 degrees, 20 minutes. Okay, 75 degrees, 20 minutes, 00 seconds. All right, so these are the sum of the left deflection angles and the right deflection angles. Okay, remember their difference should be equal to 360 degrees. So we should get the difference. Okay, so the difference, let's denote this as difference 1, difference sub 1. It does not matter kung sino ang mas mauna. We should get the absolute value of the difference. Okay, so the absolute value of the difference is 435 degrees, 16 minutes, 30 seconds minus 75 degrees, 20 minutes, 00 seconds. Okay, so the difference should be equal to 359 degrees, 56 minutes, 30 seconds. Okay, so this is short of 360 degrees. Tama? This is not equal to 360 degrees. That means there is an error of closure. Okay, we have an error of closure. The error of closure now, the error is equal to 360 degrees, okay, minus this computed difference. That's 359 degrees, 56 minutes, 30 seconds. Okay, and if you subtract that one, the answer should be 3 minutes. Okay, 0 degrees, 3 minutes, 30 seconds. Okay, so that is our error of closure. Okay, it's stated here that the error of closure should be it should be uniformly distributed to all the angles. Ibig sabihin, pare-parehas dapat ang error. Error is the same for each angle. So we should divide this error to each of the angles. Okay, but take note here that we should be careful whether we add or subtract the error. Okay, but we need to solve for the correction first. The correction is just equal to the error, the 3 minutes, 30 seconds, and divide this by the total number of angle measurements. So we have 1, 2, 3, 4, 5, 6, 7. So this is divided by 7. Okay, this is equal to 30 seconds. Okay, so this is equal to 30 seconds. This is the correction to be applied to each observed deflection angle. Okay, so we just write 0 minutes 30 seconds. Okay, this is the correction and we should apply this to each of the angles. Okay, ngayon ito yung sinasabi ko, be careful when analyzing the observed value kasi 'di ba short tayo ng 3 minutes 30 seconds. Short tayo sa 360 degrees. The difference should be 360 degrees between the deflection angle to the left and the deflection angle to the right. Okay, we need to widen. Kailangan pa nating palakihin yung difference, tama? Kasi kulang nga eh. Kulang tayo ng difference. It's only 359 degrees, 56 minutes, 30 seconds. Okay, and to widen this difference, kailangan tayong mag-add doon sa to the left at mag-subtract doon sa to the right. Tama? Okay, syempre, dapat palakihin natin ito, pababain natin ito to widen the difference para maging 360 degrees ito. That is why, ang gagawin natin dito is to add itong correction natin to all angles to the left and we need to subtract itong correction natin to all angles to the right. Okay? So, yun na yung adjusted angle natin. So, let us write our adjusted deflection angles. Okay, so we have our adjusted deflection angles. Okay, for A prime, this is the observed plus or minus the correction. Okay, so the observed is 28 degrees, 25 minutes, 0, 0. And this angle is to the left, right? So if the angle is to the left, we need to add the 30 seconds. Okay, if we add the 30 seconds, we have 28 degrees, 25 minutes, 30 seconds, and still to the left. Okay, for the second angle, B prime now is we have an original observed angle of 68 degrees, 0, 3 minutes, and 30 seconds, and this is also to the left. That is why we need to add the 30-second correction, and this is now equal to 68 degrees, 0, 4 minutes, and 0, 0 seconds, still to the left. Okay, for C prime, this is the adjusted deflection angle for angle C. The original is 120 degrees, and then 34 minutes, and then 0, 0 left, and then plus 30 seconds. This is equal to 120 degrees, 34 minutes, 30 seconds, is still to the left. Okay, for angle D, okay, remember angle D is an angle to the right. So in this case, the original is 58 degrees, 30 minutes, 0, 0 seconds. This is to the right. We need to subtract the 30 seconds. Okay, remember, we are widening the gap between the to the left and to the right deflection angles. We are adding the correction to the angles that are deflected to the left, but we are subtracting the correction to the angles deflected to the right. That is why we are subtracting in this case, because angle D is an angle to the right. So 58 degrees, 29 minutes, and 30 seconds to the right. Okay, doing the same for the remaining angles. we have E prime, F prime, and G prime, we will come up with E prime will become 108 degrees, 14 minutes, 00 seconds, and still to the left. You should verify this one. You only need to add the correction of 30 seconds. For F, we are going to subtract because it's an angle to the right. So we have 16 degrees, 49 minutes, 30 seconds. And this is still an angle to the right. For angle G, we need to add the correction. So it becomes 110 degrees, 01 minute, and then 00 seconds is still to the left. Okay, so these are now our adjusted deflection angles. Okay, if you need to check, you can check. Okay, so now we can check. How do we check? By getting the sum of the deflection angles to the right. Okay, if we get the deflection angle to the right, we have 75 degrees, 19 minutes. Okay, by adding this one and this one. Okay, if we add them, we get 75 degrees, 19 minutes. If we get the sum of the deflection angles to the left, by adding ito, this one, this one, this one, and this one, 5 angles, we come up with 435 degrees, 19 minutes, then 00 seconds. This is also 00 seconds. Okay, and if we subtract the two, okay, now we denote this as the difference 2. If we subtract the 435 degrees, 19 minutes minus 75 degrees, 19 minutes, we should come up with the required difference of 360 degrees. And this one checks out with the geometric relationship between the angles. Okay? So this is now our adjusted deflection angles. And finally, we are now going to tabulate our solutions. Okay? So let us tabulate by creating a table. So I have already made a table here. So this is what our table should look like. So for the first column, we have the station. So our stations are actually the points A, B, C, D, E, and F. Okay. For the observed deflection angles, we should write here all the angles that are initially given. Okay. So I'm going to write that here. So I have already made the whole table for you. The first column are your stations. For the next two columns, these are your observed deflection angles. There's a separate column for angles deflected to the left, and separate column for the angles deflected to the right, as you can see here. So we get the sum of these two columns together, and there's another column for the correction. We should state here if we add or subtract the correction by indicating the plus sign or the minus sign. And then for the last two columns, we have the adjusted deflection angle. We have already solved for these values a while back. Just plug in these values in these cells and that's it. Okay. We also have a separate column for the left and right deflection angle to come up with the sums, and you can check if the difference of these two columns is 360 degrees later on. Okay, that's it for the deflection angle traverse. I hope you have learned something. If you have any questions, do not forget to write them down in the comment below, or you can ask me directly in our Facebook group or on my email. Okay, so thank you for listening.